Alright guys, in this video we're just going to go over the basics to graphing log functions. Now we have solved log functions this past week, but we actually haven't graphed it. Now after this video you may have some questions, but really my main goal is just to get the basics down, okay? So now let's go back to your quiz that you took about 2 days ago. This is an example of an exponential equation. Okay, an exponential equation. Now, we've dealt with this a lot this past week, so you know as well as I do that the horizontal asymptote is running, horizontally, you know, and so you'd say the horizontal asymptote would be y is equal to 0. You know that the range, you should know this, the range is going to be, so the range, and I'm writing with my mouse here, so it's going to look weird. My range is going to be y is greater than 0, and your domain, your D for domain, is going to be all real numbers. All right? Now, what a log function is. Now, if you remember back from a couple of days ago, I told you that if you have an exponential function, exp, exponential function, the opposite of an exponential function is a log. All right? I don't know if y'all just heard that. I think I got an email. But all right, there we go. It's a log function. So an exponential and a log are two different things. Now, let me show you what a log function looks like. All right. In this picture here that I'm showing you, the red is an exponential function. The green is a log arithmetic function. So these are mirror images of each other. Okay. Now, a couple things to note, and that is here with a exponential function, let me see if I can draw this. My asymptote is running horizontally. But remember that, going back to this picture, the difference between, or the inverse of an exponential is a log. And remember, inverses, everything gets switched. So if you had a horizontal asymptote for an exponential equation, then that means the log, you're going to have a vertical asymptote. All right, so just a couple of things, and that is, with a log function, what you have is a vertical asymptote. All right, so in this case, it's going to be x is equal to 0, unless there's a transformation. And we're going to talk more about transformations in this class, or in this unit, with logs than we did with exponential equations. All right, so let me kind of give you a couple examples. All right, okay, now here's a little online graphing calculator I use from time to time. What I have just done is I have graphed the parent function. Remember, the parent function is what everything gets compared to. Now, notice what we have here. See how this graph flattens out right here? You know as well as I do, is where the graph flattens out is where our asymptote is going to be. Okay, so let's talk about some transformations. What if I decided to do this? Log, parenthesis, x minus 2. Let's see what happens. All of a sudden, it's been shifted over to. Okay, now remember x minus 2. Anything in the box is always opposite. So whatever is being subtracted or added to the x is always going to move the graph back and forth. So if I say x minus 5, let's see what happens. I go to the right. Oh, there it is. I went 5. Now also notice that where the graph flattens out is now way over here. So what that means is that the asymptote has now been shifted 5 units to the right. All right, so let's see if I can take a picture of this real quick. So now all of a sudden, I had to change softwares here. So now all of a sudden, my asymptote is sitting right on the 5. So where the graph flattens out is where my asymptote is. So now it flattens out over here at 5. So that means my vertical asymptote is going to be x is equal to 5, because it intersects the x-axis. Let's try again. Let's go back to my online graphing calculator. So let's say if I go log, and I'm going to get rid of my parent function. You don't need to see the parent function anymore. All right, so let's say if I say log plus 3. Well, let's see what happens. Graph There it is. It's been shifted over 3 units. So once again, where my graph flattens out is where your vertical asymptote is going to be. So you would say my vertical asymptote is x equals 3. All right. Now let's see another question. All right. Let's see what happens here. Let's say if I say x plus 3, and all of a sudden I add a 3 to it on the outside, and if I graph it, look what happens. It goes up 3. All right. So originally it was x plus 3, and when I graphed it, it was right there. But actually, let me write it up on top here. It might be easier to see. X plus 3 plus 3. Oop. Plus 3. I'll get it right. Graph. There it goes. It gets shifted up. Okay. So anything that gets added over here shifts my graph up. All right. So let's say if I decided to change it up a little bit. All right. Let me clear that out. So let's say if I say x minus 2 minus 3. Well, the transformations is x minus 2, it should be 2 units to the right. The minus 3 should be 1 unit down. So let's see what happens when I hit graph. There it is. 2 units to the right, and it shifted down 3 units. All right, so 2 units to the right, and I shifted down 3 units. All right, so let's do a couple of examples here. All right, the first example we have here, all right, for question number 19. All right, now, with this type of graph here, sometimes in your graphing calculator, for some odd reason, it doesn't continue down, and you will need to write something like this. And basically, I don't know why the graphing calculator does not do this, but it needs to. So in an example, you need to make sure that you draw a line continuing down. Okay, so x minus 3, we know we shifted to the left 3 units, so that's our transformations. Now, the asymptote. Remember, our asymptote is where the graph flattens out, and it flattens out right there, and it flattens out at x equals -3. So that's my asymptote. All right. Now my intercepts. This is where the graph intersects axes, the different x and y axis. So this is where it intersects the x-axis, which is going to be at -2, 0. And this is where it intersects the y-axis, which is going to be, looks like 0, we'll just say 0.5. Okay. So this is my y-intercept. This is my x-intercept. Okay. Now, when we're talking about increase and decrease, we'll talk about that when we see each other again, the asymptote, and of course in behavior we'll talk about all that. But what we're paying attention to mostly is the transformations. All right, so the transformations of this for question number 20, you have negative, which is reflection, x minus 2, which means you'll be going to the right 2, and plus 5, which means you'll be going up 5. Okay, now remember, continue to draw the asymptote. There it is. There's my asymptote, which will be x equals 2. Because remember, if I was to keep the asymptote drawn, if I drew this asymptote, it cuts right through 2. Okay, now, so the transformations, the asymptote, it looks like the intercepts, it will eventually intersect the x-axis, but way, way, way over here, and we'll talk about that once we see each other again. And so let's see what else. Zeros, remember zeros is where the graph touches the x-axis, and we'll talk about that. So basically this entire video was just to get you down with the basics. All right, so let's look at this one. Question number 16. X minus 2. Well, that means I'm going to the right 2. Plus 4. That means I'm going up 4. Now remember, your graphing calculator is going to show this. You need to continue the line continuing straight down. All right, remember this line that you continue straight down, this is going to be where your asymptote is. So it's going to be x is equal to 2. All right, I'm hoping that you're noticing something, is that where you shift is where your asymptote is going to be. All right, so let's go back to the one. See how I shifted 3 units to the left here, and notice my asymptote is -3? Where I shifted 2 units to the right here, my asymptote is x equals 2. So observations that you need to see. All right, so that's basically it for right now. All right, and we'll talk more about that when we see each other on Monday. All right, so hopefully you understand the basics of a logarithmic equation.